Bismillahirrahmanirrahim. Welcome back to my channel. I'm back with a video, and this video is going to be another video where I'll be using my HackRF software-defined radio platform to transmit a signal, and I'm going to try to receive that signal using my RTL SDR dongle. But this video is going to be a little bit different, and this video is going to be all about quantum noises. What are quantum noises? How I can generate these quantum noises, and what can I do to generate these quantum noises using Python flow graph. So basically, I'm going to use a Python code, and we're going to use, just like any other noise. Noise can be treated as a random model, uh, as in stochastic processes. And the difference between quantum noise is it's usually a random variable, even though if the electromagnetic field that exists, even in the absence of any signal or any photons, there is some type of a fluctuation which is there in vacuum. That is actually known as your quantum noise. This is how quantum noise is being defined in the literature or in quantum mechanics and things like that. There will be certain parameters that we will be tweaking around to actually generate this type of a random noise, a quantum noise. All right, one thing you also need to notice when you do this on the spectrum, it looks like it will have a very broad band spectrum. Compared to, like, for example, if you have a jamming signal that have a burst of a signal, but this will occupy a very broad spectrum. So for that, we're using Heisenberg product, Heisenberg constant, which I found on internet, and this is basically what these constant are being defined. We're taking a variation near I and Q and multiplying it by these variables, which are called squeezed state. This is probably where the state where the uncertainty in one quadrature reduced, uh, squeezed, while the other one is increased. So this is being done here on the code based on this, and this equation is available online. Then, of course, you can also use noise as being a random function, and based on this, you're generating these vacuum noises. And of course, these are, since they are quantum noises, they are rotating as well. So basically, this part of the code that you are seeing, that is actually generating these noises based on the mathematical function. Not exactly the product, not exactly I don't have the hardware to actually produce this, but you can use the code itself and the equation which is present online. You can just simply code this. The next step is these things are being converted into a bin format, which is done by this code that is converting these IQs in a form of a bin, so I can easily transmit this. Certain things, the rotation part of the quantum noise is being controlled by these two parameters. I can change the rotation frequency, and I can change the rotation parameter R as well. So this is being done, and then after that, this is being transmitted using my HackRF. So what I will do first, based on this code, which is called a squeeze noise rotating code that I have used AI or ChatGPT to generate this, I will show you the output of this. So once you have this code running, leave this code as is and go to your terminal and simply run this. So when you run this code, just simply go in and Python 3, this is, I named this. What it will do, it will generate those IQ symbols based on the random processes and the equation that we have defined in our code, and it will give you a format of a bin format. And that bin format, we're going to use HackRF transfer to transmit that at 433 megahertz. So you will see the difference. So this is how this looks like. All right, this is what the rotating noise, quantum noise, looks like. This is what is being plotted. Now you can change this parameter. You can go back to your code, like for example here, and change these parameters. Let's change this to like 0.2 and change this frequency to 10 hertz, and let's see what happens. So just simply save this file, save this, and let me just move out of this, Control Z this, and run this again, and you will see you will see totally a different figure. Why? Because of the rotation, the noise spectrum will change. So we'll just wait for it to pop up. So this was the earlier version. Just close this because probably close this guy. Here we go. So this is a little bit different as compared to the previous version. This is more sort of like an ellipsoid shape. So this is the type of a signal that you're visualizing. So after when you run these code, it will generate you that particular uh, uh, IQ file, and that is being converted into a bin file. Now you're ready to transmit this file. Just simply go to HackRF transfer. Okay, so wherever you have, when you run this code, ls this, you will see this squeeze underscore quantum noise dot I underscore IQ dot bin. This is the one that you are going to transmit. So just simply squeeze 5, just go to HackRF, rotating, sorry, this one. So rotating squeeze noise, just simply hit enter. This will start transmitting it from my HackRF. Now, in order for me to visualize this, I have my RTL SDR dongle, which is connected with GQRX, and this is the type of a spectrum you will see this. As I said earlier, you won't be able to see this that ellipsoid type of a pattern here or a circular pattern on your IQ on your waterfall graph, but you can clearly see the noise is broadband. It's like throughout the spectrum this is present. Now when I quit transmitting it, you will see the change in the spectrum as well. So let me just control Z this, let me stop this, and all of a sudden my spectrum went down, and this is what you are seeing right now. So let me try to transmit those files again one more time, and then HackRF transfer. So rotating squeeze noise IQ bin, those are the points which are being plotted as you saw it earlier on that Python graph. And here you go. So this is what you are seeing. So it's a very broadband spectrum of these quantum noise that is being transmitted via my HackRF, and I'm receiving this at 433 megahertz using my RTL SDR dongle. Even though so that's the idea behind this, and this is what I wanted to show you, that using simple mathematical definition of quantum noise, you don't need to have a hardware. You can generate this noise, and you can like transmit that using your HackRF, and you can visualize the spectrum. So I hope you find this video helpful. If you have any questions, just leave it in the comment section, and please don't forget to like and subscribe to my channel, and thanks for watching.